Hello and welcome to the 6th episode of Farm Survival Log DevLog. Last time I introduced my game server, I talked about why I'm making it, what it is for kinda, but I didn't really dive into how I'm making it. And I wanted to have a bit of a technical talk, so today's devlog is gonna be all that. I'll go over the to-do list of my server in detail, and as I talk about each, I'll also try to explain how each is implemented. So the first in the list is Authenticate. We all know what authentication does. This allows users to log in and access their own game. By definition, authenticate is to prove something is real or true, meaning there are cases where something is not real or false, such as malicious users, and a server should be able to respond to those cases by invalidating or preventing its access. I implemented login of this game using Firebase Authentication. Now, just to share a bit about what Firebase is, Firebase is a cloud service platform designed especially for mobile and web applications, or at least that's how I feel about it. And authentication is one of the services they provide, which is supposed to make authentication easier. However, this service is not a must-use thing to implement login in my game. I'm definitely not using this feature to its fullest or the way it is supposed to be used, but this seemed not too difficult to implement, so I gave it a try. All this does to my game is it adds a layer of user data which can eventually lead to users' player data. So there is this conceptual difference between user and player here, user for authenticating and player for game playing. Okay, so knowing that I'm using Firebase Authenticate this way, here's the light introduction to my login system. When a user wants to log in, a request is sent to the game server. Server then checks with Firebase to see if the user exists. If it's an existing user, server looks for the user's player data in database and sends it back for the user to look at. If it's a non-existing user, server treats the user as a new user, initializes and saves the new user in player data and sends the player data back. This may not be the best way to implement login, but I think this at least makes my server to be at the center of authentication. And thanks to Firebase, I can also use few of its provided functions. So, say I found a malicious user, or I don't know, maybe I just want to play a prank on one of my friends. I can simply disable a user in the console, and just like that I can easily ban a user from playing. So who knows, this may come in handy later. Number 2 in the list is running the main game logic, and this is for sure thing because it's a game. My server really is just a simple program that was built on top of Express. Express is a back-end web application framework for Node.js, which makes web service implementations easier. Some say this is the framework that made Node.js to be so popular for web programming, and I can kinda see why. It really does have pretty much everything necessary for successful request handling. I only had to do a little bit of work on top of it, and soon my server was ready to talk to players. All that was left was for the server to know how to serve players. What I meant by that is updating data according to players' gameplay. Things like processing choices, item uses, updating and showing rankings, and more. So you can think of the game server as the real hands-on work of the game. Every changes to player data will be done by the server and the server alone, while game clients keep themselves busy trying to look good with the data that server sends. Once the server is completed, I am going to upload it to a cloud virtual computer for it to be available 24/7. But there's just one thing that I need to keep in mind for this. How do I get all the clients to know the address of my server? Of course, I can just have the address in the client code, but then what should happen if the address changes for some reason? Will I have to fix and rebuild the game every time this happens? This is where Firebase Remote Config comes in. It's a service that allows me to publish key value pairs data. It's also good for A/B testing, which I know nothing of. But the point here is that I can always access Firebase Remote Config because it's not address driven, it's account driven. And I can use it like a login server to return the actual game server address. So if I ever need to use a new address, I can simply enter in the new address in the console and publish it. I made my game client to always fetch everything from the remote config first on its startup, so that it always knows the newest and connectable address every time. I also added few more variables like server state. Should the server need maintenance or just a break maybe? I am planning to switch this value to 0 and let all clients know the game server is not currently available instead of having a spit out page not found exceptions. Last but not least is updating and storing data. Some of you might see this as a sub-part of the second point that I've just made, but I really had to think this through because of cost issue, and so I thought this deserved a separate point on its own. Firebase provides two different types of databases. One is real-time database and the other is Firestore. They both are non-relational databases and you can use both in similar fashion. The main difference I think is their pricing policy. Real-time database charges you for the amount of data that you fetch. Bigger the data, the bigger the cost. But I believe it doesn't charge you for updating data though. Firestore, however, charges you for the amount of times you fetch or update data. No matter the size of data, the same number of querying will always cost the same. At first, I was sort of tossing around both to choose which one to use, but then my light bulb suddenly lit up and I decided to use both, or rather, decided to take only the advantage of each. I usually categorize data in two types. For data like items and stages, I call them model data or game data. So these are the data that run the game and are not specific to any player. I call the other type player data, which is basically player's progress. The thing about game data is that there's usually a huge amount of it, but it never changes so often, and so I thought Firestore's pricing policy was perfect for this. All the game data is for the cost of only one read. On the contrary, player data are fairly small and are updated very often. Real-time database seemed more efficient for handling smaller data, and so this is what I'm going to use to store, update, and fetch player data. There's one more thing I did for player data, and that is using Redis, which is a renowned key-value in-memory data structure store. A lot of developers add memory caching layer to their server for faster fetching, or as far as I know, and I'm just doing the same using Redis. I should be able to make way less fetch cost to real-time database with this, and since updating costs nothing, I'm hoping this to save my wallet. So, authenticating users, running the game, and updating saving data. These are the three main tasks given to the server. You can see that I have a huge reliance on Firebase, and that is because, as I said in the last video, I simply got interested in Firebase and I wanted to see what it's like. I don't know, I might have ended up with better server if I looked into AWS or Azure, who knows, but wrestling Firebase has been a good experience so far and I'll definitely consider using it when the time comes for my next game. So then, do I recommend Firebase for server development? After everything I said, no. I know I've spent pretty much the whole video talking about the goods of Firebase, but I must admit deciding to use Firebase for server was a bit of a mistake from the get-go. I felt as though Firebase was intended especially for serverless apps, whereas mine is absolutely server-full. Firebase itself can do most of the jobs a simple server can do. It's just a matter of knowing what services are available and joining and using them together. If one's in a situation where a simple server-like behavior is required, but when creating a server is too much of a hassle, I think that is when Firebase can really shine, or cloud service in general, I think. By the way, Firebase have really great tutorial videos. This guy can really talk well. Of course, implementing is always a different story, but if you're interested in Firebase, their videos can really start you off. I talked a whole lot of things today, but I'm still only a junior programmer and I'm still very uncertain about so many things. I know today's video didn't have enough detail for everything. Still, if any of you can spot a hole, please do point it out in the comments and I'll try to fix it. Also, any suggestions, feedbacks, questions, or just any game-related talks are welcome too in the comments, so leave them down there. Thank you as always for watching, and I hope to catch you in the next one. Bye.